Hi, I'm Rudiger Grammes, and I'm going to tell you what observability is all about and what you should bear in mind. What is observability? The ability to measure the internal state of an application based on its external outputs. In concrete terms, this means that the application has dedicated interfaces through which it communicates how it is doing and how it is performing. Observability essentially has three elements. Logging is about recording events in the system, errors that have occurred, warnings, information. This information is written to a log. Monitoring is about observing the current status of the system. Information is often displayed here in aggregated form, such as the number of errors in the last 5 minutes. A special form of monitoring is tracing, where you can track how requests run through your system and where they take a particularly long time. Alerting is closely related to monitoring and notifies you of important events in the system, such as defined threshold values being exceeded. An alert usually requires something to be done in your application. Why do we need this? There are 4 main goals that we want to achieve with observability. The most important goal is to detect errors in the application as early as possible, preferably before they affect the user of the application. We use monitoring to detect these errors, while alerting enables us to act quickly. If an error occurs, it must be analyzed and rectified. Information from logging and data from monitoring help us to do this. Observability also has benefits apart from errors. Monitoring provides us with information about the performance of our system. With monitoring, we can see whether the performance of our system has improved or deteriorated after a release, but also whether a system is running far below its capacity limits and whether resources can perhaps be saved. Observability can make the added value of an application visible. That is what the application brings to our business case. For example, the number of clicks made or registrations completed. In the following, I will introduce you to best practices that you should consider when logging. I will focus on the 4 most important points here. Use structured logging, usually in JSON format. Structured logs are easier to analyze automatically. This makes it much easier to process the logs in downstream tools, which greatly simplifies the analysis of the logs. Aggregate your logs in a central location. If you first have to search for the right server and the right log file when an error occurs, this is a major hindrance. Especially in the event of an error, you will lose important time. Tools such as the Elk Stack or in the cloud, the tools of your cloud provider can help you with this. Your log entry should contain all relevant information. This includes at least a timestamp, a severity level, and a meaningful message. Context information helps you to classify a log message in a context. For example, a request ID helps you to bundle all log messages for a user request. With a trace ID, you can even do this across multiple systems. Define severity levels for your logs, and clearly specify what is to be logged for which severity level. This sounds simple at first, but it is often difficult to predict which information is particularly relevant when troubleshooting. Use the experience you gain in production to gradually improve your logs. Reminder, we use monitoring to observe the status of our system. You should observe the following best practices. Measure the right things. What are the right things? A health endpoint that reports whether your application is healthy and can handle requests is essential. Without this, an application often cannot be operated at all. Measure everything on which you have defined a service level agreement or a key performance indicator. If you don't measure these values, you can't prove that you are meeting your contractual obligations, and you can't see whether you are achieving your business goals. Measure the utilization of all limited resources in your system. You need this information to send alerts when the system is approaching these limits. Measure the error rate and the type of error that has occurred. This information gives you an indication of whether your system has a problem. The error rate is more informative here than the number of errors, as even a small number of errors can indicate a fundamental problem with a low load on the system. Also measure everything that is crucial for the performance of your system. This will help you to identify performance problems and optimize the performance of your system. In most systems, this is particularly everything that has to do with input and output, that is memory and network access. Sometimes you also have to prioritize when monitoring, so start with the most important metrics. These are the metrics that are closest to the users of your application. The latency at the database helps you with troubleshooting, but the latency at the web server tells you the most about the performance that the user sees. If you are not sure what you should measure, use sensible defaults as a guide. One such default is the Google Golden Signals. Measure the latency, traffic, errors, and saturation, that is the utilization of your system. Please note, these metrics are particularly relevant for web applications. Other types of systems, such as a batch process, have other relevant metrics. Monitoring tools support you in storing and visualizing your monitoring data. In the open source sector, for example, the combination of Prometheus and Grafana is widely used. Tools such as Jaeger support you in tracing your requests across multiple systems. Commercial tools such as AppDynamics or Datadog bundle these functionalities and also help to extract additional performance data from the systems. These tools are also known as Application Performance Monitoring, or APM for short. Alerting informs us about important events in the system based on the monitoring data. You should observe the following best practices when alerting. Define relevant threshold values. Warn before your service level agreements are violated or application thresholds are exceeded. Also define alerts specific to your business case. For example, an alarm could be triggered if an unnaturally high number of users register in your system, or if the number of purchases suddenly plummets. Define severity levels for alerts. A warning can be dealt with on the next working day, but a critical alert may need to be responded to immediately. Documents the processing and resolution of warning messages. It must be documented whether and how the problem was solved. This helps you to coordinate troubleshooting and stores important information in case similar errors occur in the future. Many monitoring tools offer this functionality. Alternatively, an alert can be automatically entered into a ticket system, for example. Alerting is the interface to your support processes. Ensure that alerting provides the information required for support. Alerting must be integrated into the support processes. It must be clearly defined who has to do what and when for which alert. Avoid giving unnecessary or too frequent warnings. This leads to warnings being ignored. Warn about important events where something needs to be done actively. If you also want to be aware of less important events, control them on a separate channel. In a nutshell, these are the most important best practices you should follow for observability. Thank you for listening.